All right, everybody. Welcome to Graphing Quadratic Equation Vertex Form Part 2. We're going to begin a little differently. I guess one of the reasons why I missed you guys is because maybe if you were here, you would have told me to maybe finish the graph from Part 1 and actually finish what I was doing. I'm sure someone would have said something. So before we get into the crux of Part 2, we're actually going to finish our Part 1. Okay. What I was supposed to tell you guys is, notice that the vertexes are the same, so the graphs would be the same. So you can either graph in standard form, or you can graph in vertex form. So we get the vertex. In vertex form, you get it right away. In standard form, you have to do a little bit more work. But if it's in standard form, it's still a lot faster to do it this way than it would be to complete the square. That's going to be a little bit more involved. So let's finish the graph. So I'd already shown you we're at 3, -1. And there is our 2, 0 and 4, 0. And 1, 3 and 4, 3. And we have our graph finally finished, okay? Now, if you're asking and looking and say, well, that looks a little bit wider than the ones we did the other day, that's because these are a little bit wider, okay? So on the other pictures, when I always go like that, that's what we have. So if you spread your x's apart, of course, it's going to look a little bit wider, okay? So this is our standard when a = 1, and that's the graph that we were doing. Okay. I'm going to swing you around, take a little adjustment. If you get dizzy, like I always say, close your eyes. But we're going to go ahead and start part 2 here and let you guys get started. Okay, here we go. Okay, so I've got a lot of this kind of pre-prepared, so I know that you guys are going to have to, pause the video and, get some of this stuff down. So what I would like you guys to do to get ready so you can kind of just flow with me, because I really am trying to show you how fast this could actually be. So what we're going to do, and this is the way your assignments are going to be, is we're going to do these 4 problems together, okay? And they're all going to be in our vertex form. And we're going to put them all on one graph. And you can already see I have the assignments that I want you to do this week. 4 problems here that we'll put on one graph and use decimals to check. And then another 4 problems that you can do later in the week and just have decimals to go ahead and check. So what I would like you guys to do right now is to maybe set up these 4 problems right here, okay? Organize it however you want in your notes, all right? Organize it however you want in your notes. We're going to talk about our parent graph, and then we're going to put all 4 on the same graph, and that's where we'll end our discussion today. So go ahead and pause, and we'll get started when you guys unpause. Okay, so vertex form is y = a x - h plus k. And so the 3 things we want in vertex form is we need our vertex, h and k, and we also need to identify our a value so we know kind of is it up or down, is it going wide, is it tight, whatever it might be. Okay, so here we go. So our problem is y = x - 4 squared, parentheses squared, plus 3. Our h value is always the opposite. Okay, remember that's due to that right there. But our k value is basically what our k value is. Our k value is going to be 3 because the plus k allows it to be 3. So remember, go back if you're doing negative h equals negative 4, negative h equals negative 4, you're going to go opposite and you're going to get the positive 4 with the 3. Okay? Positive 4 with the 3. So our vertex is 4 comma 3. A equals 1. And when we go to make our table, we're going to have that 13 or that up 1, up 3 taking place. This one's going to be all in black, and then I'm going to change the colors for the other one. So we're going to go 4 comma 3. Now notice the vertex form doesn't give us the axis of symmetry. The axis of symmetry would be a vertical line through 4. Okay? But you're going to notice that as we do more and more of these problems, the axis of symmetry kind of floats away. We know that we're cutting this in half. So we're at 4. 1, 2, 3, 4. Point on the left, point on the right. Point on the left, point on the right. Now, the other thing you got to remember here as you make your table is our parabola is going up. Now, usually you will graph your parabola up, but you better be careful here because it's got to go down. So we're going to add 1. And then we're going to add 3. Whoops. Sorry about that. So I can see my graph. I got a steep graph. We're going to put it up. In fact, we're going to graph it here in just a second. We have the symmetry, so these have to match. Let's look at 6. 6 minus 4 is 2. 2 squared is 4. 4 plus 3 is 7. So remember, if you're not sure, you can plug the number in, calculator, whatever, do your order of operations, and you will get your y value. All right, so here, before we graph that one, I want to talk about our parent graph. So this is going to be in black, and the first one's going to be in black. So let's go with our parent graph here. So I would like you guys to kind of graph this with me so that we can keep referring to it. So this is our parent graph. And what's going to happen, especially next year, guys, you're going to do a lot of different graphing next year. And we're going to use the word translations, and you're going to move what we call these parent graphs around. This is how every graph starts, at the origin. Then we start moving it. We might start flipping it. We might make it wider. We might make it tighter by putting on these values right here. Okay? So this is y equals x squared, which means h was 0 and k was 0. That's why we're at the center of our coordinate axis right there. These values is what moves it. And the a value is what either makes it tighter, okay, a vertical stretch, makes it wider. And so these are the things we're paying attention to. So here is our parent graph, y equals x squared. So now let's do this one. Okay, I get 4 comma 3. And we're going to do 3 comma 4. And 5 comma 4. 2 comma 7. And 6 comma 7. And I hope you can tell, it's the exact same graph, we're just picking it up and moving it. Okay, we didn't go here, we didn't make it tighter. A is 1 for both problems, so it's like just picking up and placing. That's what moving the vertex does. That is what your H and K value. So last week when you were doing the problems, you might have thought, going, oh my gosh, these are all different problems. Okay, I'm doing the symmetry, it's, I'm just plotting numbers. But what I really want to get you out of this week, and the same as last week, it's the same graph. We flip it, we move it. I've said that a few times. Okay, so let's come to this one right here. So we're going to do y equals negative x minus 2 minus 1. And we'll do this one in red. Okay? So a couple things I might do here. Skinny friend, I might put in for my A value. So remember the negative doesn't have to be by itself. And let's see what we get. So my vertex is 2, negative 1. We go opposite. That is the same, so it's 2, negative 1. So I'll just put the point down. And then we have 1 and 3. And we have 0 and 4. So it's still our 13, but you got to remember, guys, you don't add 1 and add 3. We are going down. You have to know we're going down. And so we're going to subtract 1. So that would be negative 2. So you got to really resist coming up right here. You got to do something to remind yourself that you're going down. And then we're going to go down 3, subtract 3. And because of symmetry, we have the same values. So pay attention to your H. Not only is it your H and K, you got to pay attention to whether you are going up or down. So we are here. And when you make your own graphs, guys, make everything evenly spaced. Just don't make it like this. Don't do a sloppy job. Some of you guys are turning in assignments and you're just, it's a really sketchy sketch, okay? So a lot of this is sketching, but you can do a little bit better job on your graphs. That's why I'm only going to have you make 2. Make me 2 nice graphs and show me 4 nice problems on each graph. All right, let's finish. 0, negative 5. 4, negative 5. And we've taken this graph, we've moved it, and we turned it over. Okay? So I want you to picture throughout these entire lessons, taking a graph and moving it, and we're flipping it. You're going to see the next problem here, we're going to make it tighter. The last problem we're going to do, we're going to make it wider. And that's what I really want you to get out of our Vertex Form this week. Okay? And remember, in integrated 3, you're going to be doing log graphs, cubic graphs, and the more you get about this, the better off you're going to be. And so it's really important to understand this idea of taking the original and simply moving it. So much better than what we did last week, okay, if you can really understand it. All right, let's get to our next problem here. Let's do this in green. So notice that every problem I can start out the same way. I'm going to look at my vertex. Remember, it's the opposite, so my h value is -3. Okay, doesn't matter if it looks positive. That negative h makes us go opposite every time. And so we are at -3, 6. Okay, so we're going to do some crossing over on our graphs here, but that's okay. So I have -2 and -4. And then we're going to go -1 and -5. Hope the video is not too small. I hope you got a way to kind of blow it up so you can see this right here. All right. Here we go. Part 1, vertex. Part 2, so we're no longer doing our 13, it's our 26. But since we're going down, we're going to subtract 2, and then we're going to subtract 6. So So 6 minus 2 is 4. It's -2, 4. Remember, if you put -2 in here, you will get an answer of 4. Time out. Please fix this in your problems right now. I apologize. That's a mistake that I can make way too often. Make sure I didn't make it any more times. Please get your square here. Get your square here. That's why I wish you guys were here. Next problem here, we're going to subtract 6. And we're going to do all our symmetry. We're going down. And so, I got -3, 6, and I have 2, 4. And then I have -1, -2. And -5, -2. So we see our 5 points in green. Remember, don't make a straight shape up and out, but here is our graph. -2, it's tighter, so notice you can see we basically took this problem, moved it up here, we flipped it, and -2 makes it a little skinnier. The vertex is easy to find. What you really got to pay attention to is up or down, and our 13, our 26, and the different things. And then today, in our last example here, I wanted to make sure that I worked with you on the half part a little bit. So our last problem, our last example here, we're going to go ahead and I'll do it in blue. And so I'm going to go with H and K. We're going to find our vertex. So within a matter of just a few seconds, we get -1 and 4. So we have -1 and 4. So we have 0 and -2. and we have 1 and -3. We are going up. A is positive. And we're going to go up (0.5), and we're going to go up 1.5. That's half of 1 and half of 3. So if we put in 0, we put in 4.5. And if we put in 1, now watch this. 1 plus 1 is 2. 2 squared is 4. Half of 4 is 2. 2 plus 4 is 6. So we either plug in or we use our shortcuts. All right, let's finish graphing this here. We're going to go 0 and 4.5. So I'm between 4 and 5. And then I'm going to hit 1 and 6. And -3 and 6. And if you could focus on the black, which is our parent graph, we took it up and we just pulled it out. We stretched it. So notice your value of A equals -2 going down and being tighter. Notice that 1/2 we're going up, but we are wider. Okay? And so I think I gave you a nice series here. Probably would have liked to have this one over here. We could have done that and kind of separate that. But it gives you, I hope it gives you a great idea of how to do this. So what I'd like you to do, since I know that this isn't a lot of problems this week, and I think that you can figure it out, I'd really like you to make some nice graphs. I would like you to use different colors if possible when you send it to me. I can see all the different colors, okay? I would like you to make bigger graphs with everything evenly spaced, not just a bunch of hash marks. Really take your time and really do this, because one of the things that's big in Integrated 3 next year is your ability to do graphs. And so really take your time, really do something nice. These 4 can go on one graph. Use decimals to check. Same instructions here. And what I want you to do here is that you don't always have to have a K value. So if you don't have a K value, then K is 0. So what do you think our vertex would be here? It would be 3, 0. It would be right here. Excuse me. It would be right here, 3, 0. There may be also problems where you don't have an H value, but you have a K value. Remember, your parent graph, there's nothing wrong for something to start on the graph. It can start on the x-axis, or it can start on the y-axis. Okay, this is our week 6 assignments. I'm going to make another video here real soon. That is a bonus video of the quadratic formula where we're using exact answers, that means with radicals, and imaginary solutions. And so I know those of you that are really liking the math, I want to give you that. And then I'm going to make another bonus video for those of you who want to see completing the square, just as an introduction to things that we are going to see next year. Like I said, had we been together, we would have spent about 3 or 4 days kind of completing the square. But with the limited time we have left, I want to make sure that we really hit some of the things that I really want you to have down. So stay motivated. We're almost to May 1st. Okay, so we're winding down the year. I wish you guys were here. But once again, watch the videos, take the notes, text me if you need help, email me if you need help, and I'll do anything I can for you guys. All right, I'll see you soon.